warriors, welcome to yet another power-packed bang-on session. Today we are going to discuss all the topics which have been deleted from JEE Mains but are there and important for JEE Advanced as well, right? But before I start any further, before I start with the very first topic, you guys have to let me know whether I'm perfectly audible and visible, so that we can kickstart the JEE Advanced session, which is the most awaited session. You guys are commenting, DMing that, okay, please take sessions for JEE Advanced. So here we are doing our did, okay. Yes. All right, Vignesh. So am I audible and visible? Shall I start? Shall we start? Okay. Yes. All right. But before I begin this session, the very beautiful session of today's session, I just want to let you know about Vidya Utsav. Okay, so you might be seeing that the logo of our channel, of every Vedantu channel, has been changed for quite some time, but now is the reveal time. So we are having a very huge event, which is Vidya Utsav, right? And it is happening on 1st May 2024, 12 p.m, right? So just the link is given in the description box, you can check out. And yeah, so yes, okay. And one more thing, this is specially regarding your JEE Advanced preparation. If you are looking for one-stop solution for JEE Advanced, then this is it. I have always told you that rank accelerator books, all the books, chemistry, maths and physics, all the books are absolutely amazing for your JEE Advanced preparation. PYQs, be it the pattern, like the JEE Advanced pattern, you also know that matrix type, MSQ, single correct, all the pattern related question you will find it in this particular book. And each chapter is divided into two parts, part A and part B. So how to buy? Link is given in the description box. You can buy from Amazon as well, from Vedantu as well, right? And yeah, so these books are usually out of stock. So if you find these books are in stock right away, just buy it, because you never know, it might become out of stock again, right? Yes, thumbs up. Okay, I've got thumbs up. All right. Yes, so let us begin. Okay, let us begin. So the very first topic of JEE Advanced category, JEE Advanced additional topics. Please remember, we are only tackling those topics which are not there in JEE Main, right? Because we have not touched those topics, right? So let us start with triangle inequality, which is from complex numbers, right? So triangle inequality is something which is there in your JEE Advanced, right? But not there, deleted from JEE Main, right? Triangle inequality, right? This is from complex numbers, right? Suppose you are having two complex numbers over here. First one is Z1 and second one is Z2, all right? And mod of Z1 plus Z2, if I talk about Z1 plus Z2, will be greater than or equal to mod of mod Z1 plus mod Z2, mod close, okay? And this will be less than or equal to mod of mod Z1, you can say, minus mod Z2, or simply you can just write Z1 minus Z2 as well. So this is nothing but Z1 minus Z2, okay? All right, so Z1 minus Z2 mod. This is your first triangle inequality. Now you must be wondering, ma'am, why you are writing this? What is the source of this? How are you writing this? We will study. I am just going to write two important triangle inequalities which are there in your syllabus, okay? All right, yeah. So let me just correct it. Okay, this is less. Yes, less than or equal to, right? Another triangle inequality would be mod of Z1 minus Z2. This is less than or equal to mod of, this is again same, mod Z1 plus mod Z2 mod close, and this is going to be mod of mod Z1 minus mod Z2 mod close, okay? So these are the two triangle inequalities which we are going to first of all study one by one, right? First triangle inequality we will tackle, then second triangle inequality we will tackle, and then we will solve problems based on this as well. Do not worry about that, okay? First triangle inequality, second triangle inequality. Let us start, okay? All right, yes. Let us start, let us begin. Triangle inequality. Now, what we will do is, we will draw x-axis and y-axis, okay? So this is basically argand plane. So this is your real axis and this is your imaginary axis. All right, yes. And now this is your origin. P point is nothing but Z1, right? OP is your Z1 and OQ is your Z2. Z2 is another complex number. This is Z1, this is Z2. Now understand that these complex numbers are actually considered as vector quantities as well. So let us consider this as vector and try to prove the triangle inequality first, right? So first of all, let us understand this OP is nothing but Z1 vector. Agree or not? OP vector is what? Z1 vector. OQ vector is your Z2 vector, right? And now, if you want to write Z1 plus Z2, you have to write the resultant vector, that is your OR vector. Can you see this OR vector? So this OR vector is nothing but Z1 plus Z2, okay? OR vector will be nothing but Z1 plus Z2. So this middle vector is OR vector, which is a resultant vector. Z1 plus Z2, so this is OR vector, right? And what about PQ vector or QP vector, you can say PQ or QP vector. So if I talk about this, which is QP vector, QP vector will be nothing but Z1 minus Z2, right? Yes. So first thing, let us understand this very clearly, that in a triangle, if I talk about in a triangle, two things actually. Two things in a triangle is absolutely should be clear to you, that if you take sum of two sides, it is always greater than third side, okay? And if you take difference of two sides, it is always less than third side. One by one we will tackle it, okay? So sum of two sides in triangle OPR. So we are having this triangle OPR. Consider this triangle. We are going to prove this triangle inequality right away, right now. So can you see sum of two sides? So if I talk about sum of two sides, so sum of two sides, what is this? OP. So sum of two sides is OP plus next is what? PR. Sum of two sides is greater than third side is what? OR, right? So OP, what is OP? Who is going to tell me? OP is nothing but Z1 plus PR. What is PR? PR would be nothing but Z1 plus Z2 minus Z1. So that is this Z2, right? So OP plus PR, we will talk about what length. OP plus PR is greater than third side. What is third side? Z1 plus Z2 mod. So can you see this side of inequality has been right away proved, that Z1 mod Z1 plus mod Z2, can you clearly see, is greater than mod of Z1 plus Z2. Only this side of inequality did we prove? Yes. Okay. Now let us, so using this, we have proved this. Okay. All right. Now what about this? Difference of two sides is always less than third side. Difference of two sides is always less than third side. Now for that, what we will do is difference of two sides. So this side is your Z1. Okay, this side is your Z2C, Z1, Z2. So difference of two sides, this is your difference of two sides, is always less than third side. This is your third side. This is your third side. So this is sum of two sides and this is difference of two sides. Is that clear? Is this triangle inequality clear? Okay, so this is sum of two sides, Z1 plus Z2. Can you see Z1 plus Z2 will be greater than the third side, which is Z1 plus Z2. Sum of two sides greater than the third side. Now I hope it is clear. And difference of two sides. So this is Z1 minus Z2. So Z1 minus Z2 inside the mod, obviously, because side is positive. Z1 minus Z2 and the difference can also be negative. So we are taking the mod. So difference of the two sides is less than third side. Okay. All right. So this is your triangle inequality number 1. What about triangle inequality number 2? So for triangle inequality number 2, we have to consider another triangle but same concept. So yes, we are studying this triangle inequality for the very first time. So it might be difficult for you to understand the first triangle inequality. But now that you got the hang of it, now that you understand, okay, it is very easy. Sum of two sides greater than third side. Difference of two sides less than third side. Now second part would be much easier for you. Let me show you. Okay, so now the triangle has changed. Now consider this triangle. Can you consider this triangle? Yes. If I talk about this triangle, this is Z1, this is your Z2, and this is nothing but Z1 minus Z2. So again, sum of two sides, right? OPQ triangle we are considering sum of two sides. So Z1 plus Z2 is, this is your sum of two sides. Sum of two sides is greater than third side. What is third side? This is third side, PQ. PQ is nothing but Z1 minus Z2. So this is your third side. And similarly, difference of two sides. Difference is what? Z1 and Z2 are the two sides. So this is difference of two sides is less than, this is your third side. Now you must be wondering that, ma'am, okay, you are saying greater than, less than, but now you have applied the equality over here, right? You have always applied the equality. Although you are saying greater, you are not saying greater than or equal to, you are just focusing on greater, right? So let us talk about the equality over here, because the question will have like the question, if I talk about JEE Advanced perspective, they will give you question for the equality part only. Just like your AM-GM inequality, you understand AM-GM inequality. So always what we do is AM greater than or equal to GM. But the minimum and maximum value, when they ask, what did we tell? What do we tell? The exact equality wala value, right? So now let us directly jump onto the question part, okay? Let us jump onto the question part, but before that, yes, equality part let us understand and then jump onto the question part, okay? Now equality. Let me just tell you that, yes, now let me just delete all the markings over here, and this is your thing, okay? So basically, if I talk about first inequality, let us only talk about first inequality right now. So there are two equalities, right? Mod Z1 plus Z2 can be equal to this as well. Z1 plus Z2, right? And mod Z1 plus Z2 can be equal to, can you see Z1 minus Z2 as well? Z1 minus Z2 as well, mod. Okay, so these two equalities I can clearly see. Okay, now let's talk about the first equality and intuitively think. Can we think like this geometrically? Can we think geometrically? Very easy, very easy. If you think geometrically, it is very easy. So what is happening over here is mod Z1 and mod Z2. So suppose your Z1 is minus 3 and Z2 is minus, suppose Z1 is minus 3 and Z2 is minus 4. Then will this equality hold? Just put the value and see. Will this equality hold? So yes, minus 3 minus 4. So this is going to be 7 and 3, 4, 7. Yes, ma'am. Yes, it is happening. What about if Z1 and Z2 are 3 and 4? Does my inequality hold? Tell me, very easy. Is my inequality holding true? Equality holding true? It is true. So 3 plus 4, yes ma'am, absolutely it is holding. Okay. Now can I say that one is negative and one is positive? In this case, can you tell me that my equality is holding true or not? So now Z1 is minus 3, Z2 is 4. So left hand side will become 1. But right hand side is still 7. That means this is not at all possible. This is not at all possible. Right? Yes, are you getting my point? So what is happening over here? Please understand that Z1 and Z2, if are of same sign, right? If are of same sign, then this equality will hold true. Or rather than saying this, what I'll be saying is in a different perspective. With respect to origin, I will be talking about. With respect to collinearity, I'll be talking about. So yes, this holds true. This equality holds true when Z1, Z2 and origin are collinear. Yes. So this is your 0, this is your Z1, this is your Z2. If all the three are collinear like this, or you can say Z1, Z2 are collinear, or like this as well, Z1, Z2, right? Then only we can say na, that okay, Z1 plus Z2 is equals to mod of Z1 plus Z2, right? And also Z1 and Z2 are lies on the same side of origin. You know, same sign, -3, -4, that is a trick to remember it, right? So -3, -4 will satisfy, 3 and 4 will satisfy, but when the sign gets changes, one is negative, one is positive, it is not going to satisfy. What does that mean? That this is going to be on the same side of origin, right? So this equality holds when Z1 and Z2 lies on same side of origin. And also, can you see, if I talk about vector, the angle between Z1 and Z2 vector will be 0, right, in this particular case. Okay, all right. All right, let me just go back and show you the inequality right now. So basically what I'm trying to say is, just remember these two inequalities. Now this part of inequality holds true, this becomes equal, and the left hand side of the second inequality holds true. Can you see the second one? So second one is Z1 minus Z2 is equals to Z1 minus Z2. That means the left hand side. So right hand side of inequality and left hand side of inequality holds true if 0, Z1, Z2 are collinear, that is number one thing, and lies on the same side of origin, and the angle between Z1 and Z2 should be 0. Okay, all right. Now let us talk about the left hand side. That means this wala thing, right? So this inequality and right hand side of this equality, right? This equality and this equality. So basically, similar thing. Now Z1 plus Z2 is equals to Z1, Z2. Now can you see? If my Z1 is -3, Z2 is -4, it is not gonna satisfy. And neither this 3, 4 is also not gonna satisfy. So only thing which is gonna satisfy is when both the things are on opposite signs. So one is -3, other is 4. Can you see that you are going to get 1 over here and also 1 over here? So when both are of different signs, right? That means what can we say for this inequality? That again, these are collinear points, but Z1 and Z2 lies on the opposite side of origin, right? So in this particular case, what we can say is, this is our origin, this is our Z2, this is our Z1, right? Lies on the opposite side of origin. So that means angle between Z2 and Z1 will be nothing but pi, right? Yes, okay. All right. Now you must be thinking that, ma'am, it is looking a little bit heavy to us. Yes, it is heavy if you go and understand this. It is a little bit heavy, triangle inequality. But if you solve some questions now, then you will be absolutely fine. Okay. Shall we start solving questions? All right. Yes, so let us talk about the very first question. If Z is a complex number, then we have to figure out the minimum value of this. Clearly, it is actually nothing but mod of Z1 plus mod of Z2, right? This is mod of Z1 plus mod of Z2, right? So sum of two sides is greater than or equal to third side is what we can write. Okay. So which inequality I am trying to use? So this is your Z1, this is your Z2, and so this is Z1, this is Z2, and this is Z1 minus Z2. So can you see sum of two sides, Z1 plus Z2 is greater than third side. This is what we have written. Okay. Now let us use and solve it. Very easy question. So Z1 will be replaced by Z. Z2 will be replaced by Z minus 2 greater than or equals to difference of these two. So Z minus 2 and mod Z plus mod of this is Z. Z minus 2 will be greater than or equals to mod of 2. Now mod of 2 is what? So this particular quantity is greater than or equal to 2. Can you see? This particular quantity is greater than or equal to 2, right? So what is the minimum value? 2 is the minimum value, right? So sometimes what happens is, there are few concepts in mathematics which when you study, you will feel, oh, these concepts are extremely difficult. And I agree on it. When you study, you will realize, why are we even studying it? It is so difficult. It is not getting into my brain. But when you apply, then you realize that it is actually making your life easier. Right? So can you see that triangle inequality is designed to make the question very, very easier and two-step question. So you just have to understand it nicely and apply it nicely. Okay? All right. Yes. So 2 is the correct answer. Now we are having another question. Right? Find the greatest and least value of mod z. So we are looking for greatest and least value of mod z. Now mod z is what? Mod z is nothing but magnitude, which is denoted as r. That is the first thing, and it satisfies this particular equality, right? Z minus 4 by z is equals to 2. Let us apply the triangle inequality over here. So what is the triangle? The second triangle inequality. Why I am applying second triangle inequality? Because I can see a minus sign over here, right? So the only difference between first and second inequality is just that in first inequality we have positive sign, same thing. In second inequality we are having what? Negative sign. Okay, all right. Yes, negative sign. All right, so z1 minus z2. Now can I just apply this over here? So this quantity is z1, this is minus, this is z2. Let us just apply this. Z minus 4 by z less than or equal to mod z1. So mod z1 is what? R plus mod z2. So mod 4 by z is nothing but 4 by r, right? So plus 4 by r. On the left hand side, I'll be having r minus 4 by r mod less than or equal to, right? So basically we are having, and this is nothing but 2. So we are having actually 2 inequality. This is number 1 inequality. And this is number 2 inequality. Let us tackle number 1 inequality because it is not having any mod. So r plus 4 by r greater than or equals to, this is your 2. This quantity will become 2, right? It is given in the question, greater than or equal to 2. So let us solve it, and we need to figure out what? Mod z value. That means we are looking for r only. We are after r. So r square plus 4 greater than or equals to 2r. So r square minus 2r plus 4 greater than or equals to 0, right? So if I talk about this, so b square, so discriminant is coming out as negative. That means this is absolutely true for all value of r belongs to capital R. But here is a catch. Please understand, if I am talking that greatest and least value of mod z, I am looking for mod z is what? R, which is always positive. Please understand, R cannot be negative. Okay? Alright, so from here I am not actually getting anything. This inequality gives me, okay, no matter what value of R you are going to put, this inequality will be true. So this first side is actually not giving me anything. It is giving me all values of R. Now the whole responsibility of giving me answer is on this second inequality. And what is that inequality? Second inequality, right? So this is your first inequality, which gave me nothing. This is your second inequality, which is r minus 4 by r mod less than or equal to 2. Again, now I have to open the modulus. So r minus 4 by r is lying between 2 and minus 2. So again, 2 more inequalities, right? So from here, this and this separately we need to solve. So r minus 4 by r is less than or equals to 2. So r square minus 4 less than 2r. Or what we can do is r square minus 2r minus 4 less than or equals to 0. Now from here we can just right away apply the formula method. So r will be equals to 2, basically I need 2 values, right? So first value will be, so 2 plus minus b square, that is 4 plus 4 is 16 by 2, right? So 2 gone, this is 1, this is 4. So 1 plus minus root 5. 1 minus root 5 will be negative and 1 plus root 5 will be positive, and you are getting this. This is 0. But your r is always positive. So finally you are getting 0 to this. 0 to this. So 0 to this. 0 open and this is close. So r belongs to 0 to 1 plus root 5 will be the value of r from this inequality, right? And now let us talk about the left hand side inequality. R minus 4 by r greater than or equals to minus 2. Let us solve the second inequality as well. So r square minus 4 minus 2r, r square plus 2r minus 4 greater than or equals to 0. Now if I solve it, minus 2 plus minus, same thing. 4 plus 16 by 2. So this is going to give me, okay, minus 1 plus minus root 5. That's it. Okay. So the negative root is minus 1 minus root 5, and this is root 5 minus 1. So greater than this and less than this. Again, r is never negative. So from here, r is actually coming out as the second thing is root 5 minus 1 to infinity. Right? So this is what we are getting. Both are. Now I have to take the intersection. This is close bracket. Right? So I am looking for minimum value and maximum value. So 0 to root, this is a positive value. Okay, so if I take intersection of these two, the final r, what I'll be getting is, so root 5 minus 1 to 1 plus root 5 to 1 plus root 5. So this is your smallest value. This is your largest value. So finally you are having what answer? So root 5 minus 1 is minimum value and root 5 plus 1 is maximum value of your r. Okay, all right, yes, clear? All right, let me just tell you one more time the whole question. Let us understand this question one more time. Okay, yes. So this was the question given to us. Z minus 4 by z is equal to 2, right? Now by looking at this, and we are looking for greatest and least value of r. Okay, so by looking at this nature, this is nothing but mod of z1 minus z2. Second triangle inequality I'm gonna apply over here. Okay, now if this is done, then we just need to put z1 is z, z2 is 4 by z. Okay, so I guess this part is sorted, and this part is r minus 4 by r, r plus 4 by r. Okay, so clearly if I apply, what do I get? I get this. Now we are having two sides of inequality. This side gave me r belongs to all real values. The right hand side gave me r belongs to all real values. Okay, so can you see two types of inequality? This gave me r belongs to all real values. Okay, and this gave me again two inequalities. So case 1 is this, which gave me, if you solve it, this is true for all real values of x. What about case 2? So case 2 is giving me actually two things. One for positive modulus and one for negative modulus. Positive modulus if I open, so this is positive and this one is negative. Okay, sorry, this is positive and this is the second one. Okay, all right, so if I solve it, what do I get? I get minus infinity to this union this to this, but r cannot be negative, so we have to reject it. Okay, so this is root 5 to infinity. The first case will give me, what about this? Again, if I solve it, so this will give me 1 minus root 5 to 1 plus root 5. Again, this is negative, so we have to discard negative. So negative to positive, also this will become 0 to positive. So we need to take intersection of these two quantities. If I take intersection, the minimum value will be root 5 minus 1 and the maximum value will be root 5 plus 1. Clear? Yes? Okay. All right. Yes. So this was all about triangle inequality, right? Yes. Now, shall we start with binomial theorem, right? The second deleted topic from JEE Mains is properties of binomial coefficient. Although that we have studied this topic in JEE Main because NTA was giving questions from deleted topic anyway. So that's why we have to like make sure that we are studying the deleted topics as well. But again, in depth we are going to study properties of binomial coefficients one by one, and trust me, this particular topic is extremely easy. Yes, you are going to enjoy it if you know basics of binomial theorem. So properties is the second step, second thing which you have to study. Are we ready for it? Yes. Okay. Chalo. Properties of, let us start with properties of binomial coefficients. Okay. All right. नहीं ये नहीं चाहिए. Yes. So let us first, let me tell you basics about binomial theorem. Let us recall it. That in a binomial expansion, NC0, NC1, NC2, NCn, what do we call it? Binomial coefficients. So let us understand the properties of binomial coefficients. Now, NC0 is also denoted by C0, C1, C2 and Cn. So if I write NC0 or if I write C0, please do not complain because both represents same thing. Okay, all right. Now the very first property which you all must remember, and I hope that you all remember it, that NC0 plus NC1 plus NC2 and all the way up to NCn is nothing but 2 raised to power n. How do we get it? How do we get it? So suppose let us consider the binomial expansion. I am assuming that you guys know that this binomial expansion 1 plus x raised to power n. If you expand it, what do you get? NC0 plus NC1x plus NC2x square plus NC3x cube, and last will be NCn x raised to power n. This is your expansion of 1 plus x raised to power n, right? And if you put x equals to 1 in this particular expression right hand side, what do you get? Can you see? NC0 you will get, then NC1 because x is 1, NC2, that means this thing you will get the moment you put x equals to 1. So the moment you put x equals to 1, this will become your right hand side, NC0 plus NC1 plus NC2 and all the way up to NCn, and on the left hand side 1 plus 1 raised to power n, this will give you 2 raised to power, hence you have proved it. Okay, so this is the proof of how you get NC0 plus NC1 plus NC2 and all the way up to NCn. Okay, all right. Yes. So we've had only one lecture of JEE Advanced series, which was taken by Shreyas sir, physics, wherein he told you all the he taught you all the deleted topics which were there in JEE Main, which are not there in JEE Main but are there in JEE Advanced. Same thing I am doing, and same thing the chemistry teachers will also do. Okay. Yes, extra topics I am explaining, and we are doing problems based on that as well. Okay, all right. Yes. So I hope that this is clear to you that how did we arrive to this. Now let us move on and talk about another property. One by one I will be revealing all the property. This is your second property. So this is NC0 minus NC1. Now can you see the alternate sign? NC0 minus NC1 plus NC2 minus NC3 and all the way up to NCn. This is actually 0. This is actually 0. How do we get this? What is the proof? Let us understand the proof of it. So to get actually this, we know the expansion again 1 plus x raised to power n is this. Now can you see that I need minus 1 in front of NC1. So putting x equals to minus 1 will give me these two quantities at least, and NC2 will be plus. So till now we are clear. And now minus NC3, so NC3x cube will become negative. Yes. So if I need alternate minus sign, na, alternate plus minus sign, so I have to put x equals to minus 1. So 1 minus 1 will be 0, and this is C0 minus C1 plus C2 minus C3 and so on all the way up to minus 1 raised to power n Cn. So this is how your second property becomes. All right. Yes. Clear? Okay. So you put x equals to what? -1 and you get 0 is equals to this. Now the third property, which is actually, by the way, can you see what is happening in third property? So third property actually is having C0, but we are not having C1. Then we have C2, C3 is missing. C4 is there, C5 is missing. So for that, I will need two equations. What is the first equation? So first equation is the same thing only, right? See, so first property, what is the first property? That C0 plus C1 plus C2 all the way up to Cn is what? 2 raised to power n. This is your first property. This is your second property when you have alternate negative sign. Now, if you add these two, C1 and C1 will get cancelled out, and that's what you want. You don't want C1. So C0 will become twice of what? C0, this is 0, then C2, then 0, then C4, and all the way up to, so all the odd terms will be there, and if you add, this is 2 raised to power n plus 0. Now this 2 you don't want it over here, so 2 you will delete from here, divide here, so 2 raised to power n upon 2, so this is 2 raised to power n minus 1, which is actually getting. So whenever you see, now please understand, the proof is actually important but not that important. What is important? Result is absolutely more important. So please do not just get much into the proof and you just forget about remembering the result. So whenever you see C0, C2, C4, you have to write 2 raised to power n minus 1, right? And the moment you add and the moment you subtract these two, what will happen? The moment you subtract these two, C1 will add up and C0, C2 will get cancelled out, right? C0 will get cancelled out, C2 will get cancelled out, right? So the moment you subtract these two things, can you see? Subtract. The moment you subtract, C0 will get cancelled out, C1 will become 2C1, then 3 NC3, 5, right? So this is going to be twice of, again, we are subtracting, so 2 raised to power n minus 0. Now this 2 will gone and upon 2. So again, same thing. That means third and fourth result, the result of third property and fourth property are exactly same. No difference. The final answer is exactly same. Okay? All right? Yes? So all four properties are clear. If all four properties are clear, so now is the time, the test time. Let us understand that how much you have understood this concept, okay? So which of the following is true? You have 4 options and yes, this is based on your, so this is multi-select question. And I want you all to answer this, okay? 12C1 plus 12C2 plus 12C3 and all the way up to 12C11 is 4094. Okay, so let us first solve A part. Let me solve A part, then you solve B, C, D, okay? So 12C0, we know 12C0 plus 12C1, 12C2, 12C3 and all the way up to 12C11 plus 12C12 is nothing but 2 raised to power 12, which is nothing but 4096, right? Okay, now can you see that the 12C0 is missing and 12C12 is also missing. Now 12C0 is nothing but 1 and 12C12 is nothing also but 1. So we are looking for this. What we will do is this 1 and 1, 2, 1, that means 2. So this 2 will get subtracted over here and you are going to get this as 4096 minus 2, which is 4094. That means option A is correct. Option A is absolutely right. Okay. All right. Now let us check for B. Okay. So if I observe, this is 10C1, 10C3, 10C5, 10C7 and 10C9. That means all the terms are there. All the terms are there. 10C9, after 10C9 there will be no term left out. So this is going to be 2 raised to power n minus 1. Remember which property is this? Just the fourth property. NC1, NC3, NC5. So this is 2 raised to power n minus 1. So this is going to be 2 raised to power 10 minus 1. Remember, this is 2 raised to power 10 minus 1 in the power. So 2 raised to power 9. 2 raised to power 9 is definitely 512. So option B is absolutely right. Right? Yes, getting it? Okay. Now this. Understand, please, in JEE Advanced problems, please be very attentive. Okay. So 11C0, 11C1 and last is 11C5. That means this series is not complete series. Okay. The series is not complete series. So for option C, what I'll be doing is this is 11C0 plus, so what I know. Okay, so this is incomplete series, but I know the complete series, right? 11C0, 11C1, 11C2, 11C3, 11C4, 11C5, then 11C6 plus 11C7 plus 11C8, 11C9, 11C10 and last 11C11 is equals to 2 raised to power 11. That's what I know. These are the 6 terms. Can you see? And these are also 6 terms if you see. 6, 7, 8, 9, 10, 11. 6, 7, 8, 9, 10, 11. So 6 terms are there and 6 terms are there. What we are looking for is first 6 terms. So 11C6. Can I write 11C6 as something else? Can I just write 11C6 as something else? So 11C6 is 11C11 minus 1. Remember that property. NCR. Let me remind you. Let me remind you the property. NCR is equals to NCN minus R. So 11C6 is equals to 11C11 minus 6. So this is actually 5. 11 minus 7, this is 4. 11 minus 8, this is 3. This is 2. This is 1. And this is 0. Right? So now can you see these 6 terms are exactly same as these 6 terms. So these two will add up. So we are having 2 sets of all the terms. So twice of what we want to. So let us assume this as S. So twice of S. This is S. Right? I am getting 2 sets of all the terms. 2S is equals to 2 raised to power 11. So S will be 2 raised to power 11 minus 1. 2 raised to power 10. And 2 raised to power 10 is yes. Option C is also right. A, B, C all are correct. All are correct. A, B, C all are correct. Right? Yes. Clear? Okay. So none of these is incorrect. Right? Now one thing I would like to just let you know. One thing I would like to let you know about this. This result, C part is something which is new, right? Because A and B we have studied. C part is something which is new. C part is something which is new, okay? All right, chalo. So let us, so this we have already studied, this we have already solved, right? So I'm just skipping the solution and now we are having this. Again. 20C0 plus 20C1 plus 20C2 and all the way up to 20C10. Can you see still the series is incomplete? So whenever you see some incomplete series and you have to answer that what is the value of this incomplete series, what should you do? You actually need to clearly write down the complete series which you know. So what you know is 20C0 plus 20C1 plus 20C2 and all the way up to 20C10. Then you have 20C11, right? So 20C11 plus 20C12 plus 20C13 plus 20C14 and last 20C20. Okay, all right. Now what will you do is the series, the incomplete series which is given in the question, you just mark that series, okay? So this is what you don't want to change because you are looking for this value, right? So except this, you have to change all the coefficients, and by the way, the value of this whole series, the complete series, will be 2 raised to power 20. That's what you know. Right now, start changing. What should you change? 20C11 should get changed. So 20C11 will become 20C9. So this can be written as 20C9 and this is 20C8, 20C7, 20C6 and all the way up to, can you see, 20C0. This is going to be 2 raised to power 20, right? This both the green portions, sum of both the green portions is nothing but 2 raised to power 20. Sum of these two is nothing but 2 raised to power 20. Okay. All right. Yes. Sum of green portions is 2 raised to power 20. Clear? Now, so can you see 20C0, starting from 20C0 to 20C9, we are having actually two sets, right? So 20C9 will happen over here. So now just add 20C0 and 20C0 will become twice of 20C0. 20C1 and 20C1 will become twice of 20C1, and so on. Can you see 20C9 and 20C9 are again 20C9, and can you see 20C10? I am not having any 20C10 twice. 20C10 can be written down over here, and this is going to be 2 raised to power 20, right? Yes. Now what we will do is, we will just yes, so we will just remove this from here and minus 20C10. I'm gonna write it over here. Can I do that? Because I want value of 20C0 se 20C9 tak. This 2 will also be gone and it will get divided over here. And now the last step. The last step is you just have to add a 20C10 on both the sides, because you want the complete thing, right? 20C0 se 20C10 tak ka value. So this is going to be plus 20C10. And that's it. Can you see 2 raised to power 20 upon 2 will be what? 2 raised to power 19. Now can you see minus half and plus 1? So this will give you minus half and plus 1 will give you plus 1 by 2, 20C20. This is your final answer, which is exactly this. Okay. All right. Yes. Okay. Now two new things we have learnt today. Let me just show you. So we were doing this question 11C0 plus 11C1 and all the way up to 11C5, and the answer which we got was 2 raised to power 10, that is 512. Just now we did this question, right? So same thing, generalized way if we can do it. So 2n plus 1, we should have an odd number over here. That is the first thing, because if we have odd number na, then the number of overall terms would be even. So if 11 terms are there, so in complete series there will be 12 terms. 11C0, 11C1, 11C2, 11C11. How many terms? 12 terms. Sum of first 6 terms will be nothing but 2 raised to power 2n. Here n is nothing but 5. Right? Can you relate to this result? And the second result, exactly. The second result was 20C0 plus 20C1 and all the way up to 20C10. This will be nothing but 2 raised to power 2n by 2. So it was 2 raised to power 20 by 2 plus 1 by 2, 2nCn. So plus 1 by 2, 20C10. Right? So this is the result. Okay? 2nCn. So if you want to remember the result, then this is the result. But if you don't want to, because how many results will you remember? But then I have to tell you that this is something which is standard, which can be standardized. Right? Okay. Now one more question. Let us understand one more question. Right? So whenever you get these type of questions wherein some general term is getting formed, just like your sequence and series, NC1, then twice of NC2, thrice of NC3. So can you see this is R times NCR, where R starts from, you can say it is starting from 0. You can say it is starting from 1 as well. So it is the last term will be N. So this is your general term and you apply sigma over here, you will get this. Now let me tell you one very important property, which is this NCR, which it was useful in your JEE main as well. Very important. NCR is equals to N upon R. So this N will come in front, this R will come in front, right? NCR will be N upon R, and after that you have to multiply with N minus 1, CR minus 1. So just subtract 1 from these two terms. That's it. So same property I'm going to apply over here, right? Because I want to get rid of this R. Because of this R, I am applying this property. So this is going to be sigma R equals to 0 to N. This is R, and this NCR will become N by R, N minus 1, CR minus 1. See how easy is this? Right? So that's why this R is getting cancelled out. I want to get rid of this R. Now you will say, ma'am, okay, you got rid of the R, but you got an N. N. What will you do with N? I agree that you got rid of the R, but you got an extra N. But you know what? This N is actually nothing. This N is actually doing nothing if I talk about the sigma, because sigma is in terms of R. This N can be exactly taken out. N will be outside. Sigma R is equals to 0 to N, N minus 1, CR minus 1. Now is the time that you open the sigma. So this is going to be the moment you put R is equals to 0. So R0 is N minus 1, C minus 1, which will be rejected. R0 not possible. R1, so this is 0. N minus 1. R2 is this, and the last will be N minus 1, Cn minus 1. So can you see this is the whole series? We know the result of this series. So this is going to be N times 2 raised to power N minus 1 will be the final answer of this. And this is actually a result as well. You should remember this, that this is nothing but N 2 raised to power N minus 1. Right? Clear? Okay. Yeah, so this is the property I was talking about, and the final answer you all know, N 2 raised to power N minus 1. Right? Yes. Okay. Now, can you see the same result we can just obtain by differentiation as well. So there is a technique, differentiation. Let me just show you. So if you understand this expansion, you know, very basics. Let's start with basic. NC0, ma'am, plus NC1x, ma'am, this to we know. Everybody of us know. NC2x square, NC3x cube. Now what are you saying? Are you going to differentiate? Are you going to differentiate this? How are you going to differentiate? Now we are going to differentiate this with respect to x. Let's do that. On the left hand side, if I differentiate, it is going to be n 1 plus x raised to power n minus 1. On the right hand side, NC0 differentiation is 1. This derivative is NC1. This derivative will be NC2 and this is 2. Then this is x, right? X square derivative will be 2x. X cube derivative will be 3x square. And NC3 is a constant. And all the way up to last, this is going to be n will be coming in front. NCn x raised to power n minus 1. That's it. Derivative done. Now the moment you put x equals to 1, what do you get on the left hand side? N dot 2 raised to power n minus 1. And can you see, because of the differentiation, this 2 will come in front. That's what the whole idea was. So this is going to be NC1 plus 2 times NC2 plus 3 times NC3. That's what we wanted, right? N times NCn. So that's what we wanted. So this is going to be what? By the differentiation, n 2 raised to power n minus 1. Okay, all right. Now what about this? simply the last step, the moment you put x equals to 1, you got this, and the moment you put x equals to -1, you will get this. So the moment you put x equals to -1 in here, you are going to get n into 1 minus 1. This is your 0. So yes, this is absolutely right. Okay. All right. Clear? Okay, now again another type of question. Can you see the clear difference between type 1 and type 2? So here 2, 3, the consecutive terms are in multiplication. Can you see 1, 2, 3, n? The consecutive terms are in multiplication. Consecutive numbers are in multiplication. But here can you see it is in division. So again there are two ways. The first method is using the property, right? Which property? Same property. NCR is nothing but n upon r, n minus 1 CR minus 1. And the second method is using integration method. I will tell you both the methods. Okay. So yes, NC0 plus NC1 by 2 and so on, right? So this is going to be, सबसे पहले, first of all, sigma NC0 upon R. Sorry, NCR upon R. NCR upon R. R is equals to 1 to n. Right? Yes. Did I write correctly? So the moment I put R is equals to 1, I get no, incorrect. Sorry. So this is going to be R plus 1. Yes. R plus 1, and this is going to be 0. Now it's correct. That's why I always tell you, just write the rough general term and try to obtain first, second and third term. You will get the clarity. So R is equals to 0 the moment you put NC0 upon 1. Done. R is equals to 1, you put NC1 upon 2. That means yes, right. So correct general term. We have written the correct general term. That is the first thing, right? Now, this I want to get rid of R plus 1. How do I do that? So for that I have to do something reverse, right? So rather than actually combining this NCR to this, what we can do is we can just obtain this reverse process and combine this. Okay. So can you see over here, if I have R, I should have N so that I can go back. So if I have R plus 1, I should have N plus 1 upon N plus 1. So this N plus 1 will go inside and your final sigma will become, so 1 upon n plus 1 is outside, and this is n plus 1 upon r plus 1 NCR. R is equals to 0 to n. Can you go reverse? Yes, definitely. So here n upon r was here, n minus 1 CR r minus 1. So here n plus 1 upon r plus 1 NCR. This will become n plus 1 CR plus 1. N plus 1 CR plus 1. Okay. All right. And this is 1 upon n plus 1 sigma r is equals to 0 to n. Okay. Now expand. Now you've got the rid of r plus 1. Now you can expand. So this is 1 upon n plus 1. R is equals to 0. The moment you put r is equals to 0, so this is going to be n plus 1 C1. The moment you put r is equals to 1, n plus 1 C2. And all the way up to the moment you put n plus 1 Cn plus 1. That's it. Okay. So now can you see that this is having only one missing term, that is n plus 1 C0. And we know this is 1 upon n plus 1. Right? And this is going to be 2 raised to power n plus 1 minus 1. So 2 raised, final answer is what? 2 raised to power n plus 1 minus 1 upon n plus 1. This is the final answer. Yes? Can I see yes? Charanya, absolutely right. Very good. Very good. Very good. Okay. So what did we do? We saw that this is r plus 1. So we multiplied and divide n plus 1 so that I can just combine it, because this n plus 1 can become outside, can stay outside. So now this is n plus 1 C r plus 1. This is your n plus 1 C r plus 1. Clearly this is your n plus 1 C r plus 1, and if I expand this, what do I get? N plus 1 C1. So it start with 1, right? So this 1 is missing over here. So what you can do is you can add 1 and subtract 1. Why 1? Why 1? Subtract. Why 1? Because this is n plus 1 C0. This is 1. So now this is your whole thing, which is 2 raised to power n plus 1, right? So 2 raised to power n plus 1 minus this is your 1. So 2 raised to power n plus 1 minus 1 upon n plus 1, this is what you've got. Okay. All right. Clear? Right now the same question I can show you with the help of integration, right? How do you integrate? Definite integration, right? Understand, this is definite integration. How do you integrate? Suppose you are having this, okay, px plus q raised to power n. So this n will become n plus 1 upon n plus 1, right? And one more thing, px plus q, you have to differentiate px plus q over here. So this is your p, okay. All right, and now a and b. So now a is lower limit, b is upper limit. Start putting upper and lower limits. So the moment you put b, this will become pb plus q n plus 1, right? And this will become pa plus q n plus 1. 1 upon p is already there, n plus 1 is already there. Just the basic integration, you know, definite integration. Okay. All right. Now let us do this question with the help of integration. Are we ready for it? So what will we do is, first of all, let us write 1 plus x raised to power n expansion, right? And then if I integrate it, what will I get? So I will get an x over here, x square by 2 over here. So x square by 2. So C1 upon 2. That's what we want. That means right away we should integrate it both the sides. So let us integrate both the sides. So first of all, let us integrate it, and you have to put x equals to 1, and obviously you will put x equals to 0. So let us integrate left hand side, right hand side. The moment you integrate and limit 0 to 1, so what do you get? So 0 to 1 right hand side with respect to dx, and this is also there. Now let us integrate this. So 1 plus x raised to power n plus 1 upon n plus 1 over here, can you see? Upper limit 1, lower limit 0. On the right hand side, constant integration is nc0x. Integration of this will be x square by 2, x cube by 3, x raised to power 4 by 4, and last x raised to power n plus 1 by n plus 1. Now, please, this step is very careful. Please solve this step very carefully. Now you have to put upper limit and lower limit. The moment you put 1 over here, what do you get? 2 raised to power n plus 1 upon n plus 1. The moment you put 0, you will still get something. So you are going to get 1 upon n plus 1, right? So upper limit, if you put, you get 2 raised to power n plus 1 upon this, and lower limit me, you are going to get 1 upon this. So this is your left hand side, because sometimes you just forget putting 0. You feel, okay, 0 means 0. No. 0 means something, right? And on the right hand side, if you put 1, so you're going to get C0, then C1 by 2, C2 by 3, and Cn by n plus 1. And the moment you put x equals to 0, can you see all the terms will be gone? So x equals to 0, lower limit in the right hand side will give you 0. Okay, so this is your final answer as per the integration. Right? Clear? So final answer. Okay. Now there are two, actually, yes. There is one homework question that I want you to solve with the help of integration. Right? No, actually, Charanya, chapters, if I talk about chapters in mathematics, they have not skipped the complete chapter. Okay? So there is no chapter which is new in JEE Advanced. The in between topics in mathematics, they have left in between topics, right? Yes. Okay. So in between topics are something which they have not given in mains, but they have given in JEE Advanced. So first topic was from complex number triangle inequality. Second big topic is from binomial. So properties of binomial coefficient, this is a huge topic. And the next will be from probability, right? Probability and statistics. The third topic will be. And then there are some topics from vectors and 3D geometry. And after that, we have a few portions from calculus as well. And some related to conic section, okay? All right. Okay, now, yes. Now, there are some questions which will act, some series based questions of binomial coefficient which will have product of two quantities. Now, I am going to tell you the shortcut for product of binomial coefficient, how to solve it, okay? So, this is NC0, NCR. This is NC1, NC. This, can you see N, 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 and N, N. Right? Yes. So the moment you see product, the very first thing you should do is you just add these two indexes, 0 plus R, which is R, okay? Second, 1 plus R plus 1, that means R plus 2. What we want is sum of these two index should be constant in every term. How to do that? So for that I need to change something. I need to change either this one or this one. So I will change the second term. Right? Let us change it. I am changing it. So this is NC0 will be same. So one term you have to keep it same. Another term will be NCR will be NCN minus R. Can I change it? Plus. Now NC1 will be exactly same. NCR plus 1 will be NCN minus R minus 1 plus NC2 will be same and NCN minus R minus 2 and so on, right? So now can you see 0 and N minus R will give you sum of index is what? Tell me. 0 plus N minus R is N minus R. Sum of these two. So N minus R minus 1 plus 1. Again, can you see the index is coming constant? 2 getting cancelled out. Index is throughout N minus R. If it is the case, then what will be the answer? What will be the answer? Who is going to tell me? So answer would be sum of these two. That is 2N, C. And again the constant index. Add any one. Add any two index. You will get N minus R only. N minus R. This is the final answer. 2N, C, N minus R. This is the shortcut. Okay. Alright. Now, let us apply the same thing in second property, which is C0 square plus C1 square plus C2 square. So, you will actually ask me that, ma'am, okay, you are saying product. So, product, this is the product. We agree. And we understand, okay, what are you trying to say? But what about this? This is not even a product, ma'am. This is square. Square means product. Yeah. Actually, square means product. Can you see this is NC0 into NC0? Then we have NC1, NC1. Then we have NC2, NC2. And last we have NCN, NCN. Right? Now, I told you whenever you see series of product, so you change another thing. Right? So now NC0, second term. Can you see right now the sum is 0, here the sum is 2, here the sum is 4, so it is not working for us. Sum should be constant. So this NC0 can be replaced by NCN. Do you agree or not? NC0 can be written down as NCN by the property NCR is equals to NCN minus R. Now NC1 is what? NCN minus 1. NC2 is NCN minus 2 and NCN is NC0. So I have only changed the second term. Now can you see the 0 plus N index, sum of index, 0 plus N, N ma'am, 1 and N minus 1, N ma'am, 2 and N minus 2, N ma'am, N and 0, N. So final answer, how do you write? So N plus N, that is 2N, C, and can you see any index will be N. 2NCN will be the correct answer. Yes, are you getting it? Yes? All right. Clear? Now there is actually one formula. So you saw that NC0 square plus NC1 square plus very popular, NC0 square plus NC1 square plus NC2 square and all the way up to NCN square will be 2NCN. That you saw. But this, the alternate sign, will have two values depending upon the value of n. If it is odd, then go ahead and write 0. But if it is even, then what will happen is you just have to write this minus 1 raised to power n by 2 NC n by 2 if n is even. This is the result that you have to remember. Okay. So suppose you see that, okay, so this is 3C0 square minus 3C1 square plus 3C2 square. So this is going to be 0. But if you see 4C0 square minus 4C1 square plus 4C2 square, so this is going to be minus 1 raised to power n by 2, n is here, so 4 by 2, 4C 4 by 2. So this is going to be 1 and 2, 4C2. Okay, all right. Yes, this is the result that you have to remember. All right, clear? Now, who is going to tell me the sum of this? Who is going to tell me the sum of this? I have told you the shortcut. I will give you time. This is a direct question. This can be there in your JEE Advanced examination, right? JEE Advanced examination is not that difficult. It's just that a few hidden things are there that you have been told in class, but you are not able to recall. Right now you will be able to recall MCR plus MCR minus 1. Can you see? These are the product. R minus 1 and 1. So the sum of index, who is going to tell me, is R over here. Sum of index is R. What about this? This is NC0. So nothing is written, that means NC0. And last is what? MC0. So can you see MCR, MCR minus 1, MCR minus 2 and MC0. So R is decreasing over here and NC0, NC1, R is increasing over here. But anyway, the point is, what will be the answer? Please tell me what is the answer. I am waiting, right? So M plus, what is the shortcut? M plus N. So M plus N. C, what is the index? Sum is R. Final answer is M plus N. C, R is the correct answer of this particular sum. Okay. All right. So this is the shortcut. But what is the correct method? The long method. What is the long method? Let me just show you. So for long method, you have to, can you see this is MCR and this is NC1. So you have to expand, you have to make two expansions. Yes, you have to make two expansion. The first one is 1 plus x raised to power m expansion. MC0 plus this, right? The very first expansion. Second one is 1 plus n x raised to power n expansion, right? Now what you are looking for is product. What kind of product you are looking for? So first of all, MCR and NC0 is something which you are looking for. Where is MCR? MCR, okay, MCR is this. You want to multiply MCR with NC0, right? Next, what do you want? MCR minus 1. Okay, so you want to multiply this with NC1. Okay, getting it. Okay, next term, how will you achieve? You would want to multiply R minus 2 with NC2. That means this get multiplied with this. Now, can you just understand what is the relation, what is happening here right now? So, can you see this? Yes. This x raised to power r, this term is having x raised to power r which gets multiplied with x raised to power 0. So, the final x raised to power is r. Okay. What about this? X raised to power r minus 1 is getting multiplied with x raised to power 1. So, final x raised to power is r. And same, if you multiply these two, you are going to get x raised to power r. So, basically, you are actually multiplying these two equations and you are always looking for coefficient of x raised to power r. Yes, You are looking for coefficient of x raised to power r. So just multiply these two, but you are not multiplying, right? You are just trying to, what you are trying to do is, you are trying to find out the coefficient of only x raised to power r, because that coefficient will be nothing but this only. This is actually nothing but coefficient of x raised to power r in the product of this. Okay. So 1 plus x, 1 plus x. So this is coefficient of x raised to power r. If you multiply these two, m plus n. So this is going to be m plus n CR. That's what your answer is. M plus n CR was your answer. Right? So shortcut you can apply and you can understand the... Ma'am, we should remember the method also. Is it necessary? No, no, no. See, Charanya, very good question right now. So what I can do is I can just show you all the results at one go. Ki this is this, without even proving it. I can do that, right? But what happens is, first of all, you have to understand the result, and you have to understand that how we are getting it, okay? Just the idea of how we are getting it. It's not that you have to do the proof in the examination, but what JEE Advanced will do is, they will test you the fundamentals. So they will actually give something with a twist, and what they will make you do is make you just write the expansion. So you should remember that how to obtain this sometimes, okay? And sometimes the shortcut can be applicable as well, right? But the fundamentals should be clear. That's why I am spending so much energy, okay? All right. So the final answer is what? M plus n CR. So that's what I told you, right? M shortcut. The shortcut is this. M plus n CR. Okay. All right. All right. Okay. So now we are having this question wherein 1 plus x plus 2x squared raised to power 20 is this. And then we are here to figure out sum of the coefficient a0 plus a1 plus a2. Remember that these are not the binomial coefficients. Then we are looking for a0 plus a2. So a1 is jumped. a3 is not there. Can you see? And then we are looking for a1, a3. That means a0, a2 missing. How do you tackle? Three parts are there. How do you find all these values, right? So first of all, what you need to figure out, first of all, you put x equals to 1 in the original equation. Yes, you put x equals to 1. The moment you put x equals to 1 on the right hand side, what do you get? a0 plus a1 plus a2 and all the way up to a40. That means part A. This is what you're getting. And on the left hand side, if you put 1 plus 1 plus 2 raised to power 20. So this is nothing but 4 raised to power 20, 2 raised to power 40. 2 raised to power 40 is this. So this is coming out as 2 raised to power 40. This is your first equation, right? Now the moment you put x equals to minus 1, right? Charanya, yes. I want to tell you something. See, I told you that NC0 plus NC1 is 2 raised to power something, right? Then I told you that NC1 minus NC0 minus NC1. Let me just go back. Okay? Let me just make that point. Okay? The point you were asking now, it is there, right there in this question. So first thing we did, okay? The first 5 properties we were doing. Okay, let me go back. Very easy property. Yes, these properties I am talking about. So yes, can you see? NC0 plus NC1 and all the way up to NCn is 2 raised to power n. This is the result. Suppose I have not told you the proof that you put x equals to 1. Then you have second result where alternate plus minus sign hai to 0 hai. There is a 0 if you are having, right? And then let's talk about the result part. Now third, when you have C0, C2, C4, 2 raised to power n minus 1 you are having, okay? These are the binomial coefficients. And the fourth is C1, C3, C5, 2 raised to power n minus 1, okay? So in here, in 4 formulas, what did we learn? we learned that if you put x equals to 1, you get sum of all coefficients. If you put x equals to minus 1, you get alternate plus minus. And if you add these two equations, you get what? You get C0, C2, C4, right? And you subtract, if you subtract two equations, you are going to get C1, C3, C5. So now you understand the method. Now what you can do is, so this is binomial coefficients, right? These are binomial coefficients. Now JEE Advanced will give you a question like this. So we were doing a question like this, right? Let me just go. Yes. Now cut to this, wherein I have not taught you. Yes, so cut to this. Now that you know the method, now that you know, because you can't apply the direct, these are not binomial coefficients. You know the method, you know how to eliminate A1, A3, how to eliminate A0, A2 for this, right? So, and how to get this. So the basics will help you. This is the perfect example that why you should remember the slight methods. Okay. So yes, x equals to 1, the moment you put x equals to 1, you get this. Now how to obtain B option? So you have to eliminate A1. For that you have to put x equals to minus 1 and add. Yes. So put x equals to minus 1. So 1 minus 1. So this is gone. And this is 2. So 2 raised to power 20 you are getting the moment you put minus 1, and A0 minus A1 plus A2 minus A3 and all the way up to A40. Second equation. So if you add these two now, what do you get is 2 raised to power 40 plus 2 raised to power 20 is equals to, the moment you add, twice of A0 plus A2 and all the way up to A40. Right? This 2 will go over here. So this is 2 raised to power 39 plus 2 raised to power 19. So 2 raised to power right? Divide by 2. Who will do, Charanya? Divide by 2. Right? You have to divide it by 2 as well. And now you don't want A0, so you have to subtract these two. Right? This is first and second. So if you add 1 plus 2, you will get option B. But if you subtract 1 minus 2, what do you get? A0 will get cancelled out. A1 will become 2A1 plus 2A3 and all the way up to 2A39, and this will be equals to 2 raised to power 40 minus 2 raised to power 20 upon 2. So this will be 2 raised to power 40 minus 2 raised to power 20 upon 2. So 2 raised to power 39 minus 2 raised to power 19. That's it. Right? So let me just tell you that how do we achieve this. So yes, you put x equals to 1, you get sum. You put x equals to minus 1, you get 2 raised to power 20 from here. You add these two equations 1 and 2, you will get option B. So 4 raised to power 20 plus 2 raised to power 20 by 2 is the final answer. This is your B. Now if you subtract 1 and 2, you will get your C part. That's it. Subtract, you will get your C part. Okay? Alright? Yes? Clear? So this is purely a substitution method. Okay? So f of 1, you will get sum of all coefficients, f of 1 plus f of minus 1 by 2, and f of 1 minus f of 1 by 2 will give you C part. Okay? Alright? Yes. Now double summation. Right? Double summation. Let us do double summation. NCS SCR. Okay? NCS SCR. NCS SCR. So double summation. For double summation, you have to understand that R is equals to 0 to S and S is equals to 1 to N. R is equals to 0 to S. So R, where is R? Here is R. So this NCS is actually free. So this is S equals to 1, N. This NCS, you can take this out because the sigma is for R people only. SCR. So let's just Focus on this. SCR. Now put R is equals to 0, right? So what will become this? S is equals to 1 to N. NCS. And this is SC0 plus SC1 plus SC2 and all the way up to SCS. Right? So this is what? 2 raised to power S. NCS. Sigma. S is equals to 1 to N. Now you should start putting the value of S. So 2 raised to power 1. NC1 plus 2 raised to power 2 NC2. Oh, can you feel it? Can you see it? Let me just rewrite it because I have something going on in my mind. NC1 2 raised to power 1. Something strike or not? NC2 2 square. NC3 2 cube, right? And all the way up to NCN 2 raised to power n. What is this? This is looking like an expansion, right? This is looking like an expansion. Let me just tell you. Yes, so first of all, this SCR. So sigma will go in SCR. This NCS you can take out. So NCS is out and SCR, S is equals to, sorry, R is equals to 0. So R is equals to 0, R is equals to 1. So we have done this. So this is 2 raised to power S. Can you see this is 2 raised to power S? By the formula. And now if you expand this, yes, Sohail, absolutely, I'm gonna love it. Yes. So 2 raised to power S. Now expand. 2 raised to power X. Now, can you see the moment you expand this NC1 2 raised to power 1, NC2 2, this is actually an expansion, right? But not the complete expansion. Let me just write what expansion do I remember. So this is something which you remember, right? So if I put X is equals to 2 over here, so this is NC1 2, then this is 2 square, this is 2 cube. That means that it feels that somebody has substituted X equals to 2 over here, except this. I am not having this. So put X equals to 2 over here and you will get it. 1 plus 2 raised to power N minus NC0. So this is 1. So this 1 is something which is not available. So we should remove it. So 1 plus 3 raised to power N minus 1 is the final answer. So let us just X equals to 2 if you put. Final answer would be this. 3 raised to power N minus 1. Yes, absolutely. Yeah, absolutely. Chiranjeevi on point. On point. Acha, now I want to relax because it's 1.5 hour of JEE Advanced non-stop session. So can you please teach me some Gen Z term, Gen Z slang, okay? I'm not aware about some Gen Z slang. Any Gen Z slang? Like, what do you call that? Nice. You can say no, nice, I'm liking it. So is there any slang related to this feeling or this vibe? Okay, do you know Gen Z slangs? Ghosting. Ghosting to I know. Ghosting I know. Something which I don't know. Ghosting I know. Acha, theek hai. Chalo. Chalo, let's start with probability now. Let's start probability, okay? Binomial probability theorem. I love this theorem, right? So basically in this binomial probability theorem, what do is, we actually perform the same experiment n times. Suppose tossing a coin. So we just start tossing a coin how many times? N times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. Okay? Alright? 10, n times. So if an experiment is performed how many times? N times. Okay? Now there are two things. First one is something like For example, if we are tossing a coin, so we get head and tail. So one event I consider as success. For example, if I consider getting a head as success, right? So if I am tossing a coin, if I am getting head, success. If I am tossing a coin, I am getting not head. That means tail, obviously. So I am getting a failure. So success and failure. Same thing if I am doing, if I am rolling a dice. 1, 2, 3, 4, 5, 6. So basically I am rolling a dice how many times? N times. So sometimes I will get 1, I can get 2, I can get 3, 4, 5, 6. So like success and failure I can define as per the question. So suppose getting an odd number is success. So 1, 3, 5. Getting an even number is what? Automatically the rest will be failure. Right? So yes, if an experiment is such that probability of success or failure does not change with trials, then the probability of getting exactly our success is what? Okay. So yes, now understand this binomial probability theorem. So here what we are doing is we are doing n trials. So suppose 1, 2, 3, 4, 5, 6 and all the way up to n. Right? And I am just talking about getting exactly our success. So this is n and I want our success. Right? So out of this n places, I have to be very precise that okay, out of this n, R will be success, right? So success means head is success. So head. So right? So there will be R head and rest there will be tail. So this is your success and this is your failure, right? So how to write the probability of getting exactly our success. So first of all, out of these n places, let us first select what are all those places where success will be taking place. It may be happen that first, third, fourth, right? So we need to select the R places for the success, right? Now P is what? Probability of success. So how many times we are getting success? R times. So P raised to power R, right? R times we are getting success. And rest n minus R times. Rest is n minus R times. So n minus R times I am getting failure. Where P is probability of success and Q is probability of failure. And also probability of success plus probability of failure will be what? 1. P plus Q will be equal to 1. Okay. Alright. So in this case, what happens is probability of success and probability of failure does not depend upon how many times you are throwing. Understand? Okay. Suppose I am saying that okay, one by one, starting, beginning. Okay. Let's start with beginning. I have a coin. Yes, ma'am. I will toss it. Yes, ma'am. Head means success. Okay, ma'am. Success means, head means success and success means half probability. Okay. And failure is tail. So, ma'am, okay. Failure is tail. So, failure probability will be half. Okay. Alright. And now I'll be telling you that okay, 100 times I'm gonna toss this coin. So, probability of success and failure is actually decided even before we decide how many times we are doing the trial, right? So, please understand. P and Q does not depend upon the fixed number of trials. So, P and Q are decided even before we are doing that how many times we are doing the trial, right? So, P and Q does not depend upon how many times we are doing the trial. It is pre-decided, predefined, okay? Alright, so this is the probability of getting exactly our success, okay? Let us actually do it with the help of example. Let us understand with the help of the example, okay? Alright. An ordinary 6-sided die is rolled 16 times. The probability that on exactly 5 of the rolls, either 3 or 4 comes up. Okay. 16 times I am what we are doing is 16 times. So n is equals to 16 and 6-sided dice. So n we've got. Now we are looking for what? P and Q, probability of success and failure. The probability that on exactly 5 of the rolls, either a 3 or 4 comes up is. So this is actually a success. No, this is either 3 or 4 comes up. Okay, exactly 5 of the roles, either 3 or 4 comes up. So what is the probability of failure and what is the probability of success? So success means either 3 or 4 comes, and failure means what? 1, 2, 5, 6 comes. So basically success probability is what? 2 by 6. Success probability is 2 by 6, that is 1 by 3. And what is failure probability? 2 by 3, because P plus Q is 1. Right? Okay, so 1 by 3 and this is 2 by 3. Now what we are looking exactly 5 times. So very easy, very easy. 5, okay, so overall 16 times. So 16C5, 5 success I want, 1 by 3 raised to power 5. And failure I want 16 minus 5. So 6 और 5, so 2 by 3 raised to power 11. So this is your final answer. Required probability is this. Yes? Okay. This is your required probability. Okay. All right. Yes. Next question. A coin is tossed 10 times. Probability of getting exactly 6 head. 6 head means success. First of all, n is equals to 10. Right? And probability of success is half. Probability of failure is half. And now out of 10, 6 success, 10C6. 10C6. Right? 10C6. The answer would be what? 10C6. And half, that means head raised to power 6 and tail raised to power 4. So 6 plus 4 will be always be 10. Are you getting it? Are you getting it? Why 1 by 3? Charanya is asking. Okay. Why 1 by 3? Charanya, you tell me. In the previous question, getting a 3 or 4. So when I roll a dice, what all things I can get? What all number I can get? 1, 2, 3, 4, 5, 6. So total number of outcomes is what? 6. Favorable outcomes is 3 and 4. 2 are favorable outcomes. 2 by 6. 2 by 6. 1 by 3. If 1 by 3 is probability of the previous question, Chiranjeevi is asked, Chiranjeevi, yeah. So 1 by 3 and 2 by 3. I hope that this is clear, because the rest, 1 minus 1 by 3, so that the probability of these two will be 1. Okay, all right. Okay, okay, okay. Yes, now there is one question. So till now we are doing some elementary question. Now this is the big question, the good question, right? The proper question. A pair of dice is thrown 5 times. Pair of dice. So n is equals to clearly 5. Then the probability of getting a doublet twice is doublet twice. Okay. Let us first understand. Pair of dice is thrown 5 times. So n is equals to clearly 5. Probability of getting doublet is your success. So how, if you throw a dice, pair of dice, so what is the probability of getting a doublet? Always think about single first. Very basic. Go very basic. First statement they will do 5 times. Ignore this. Just ignore this. Delete this. Remove this. Beat this. Just focus on this. Probability of getting a doublet. Twice वगैरह भी छोड़ दो. Leave that. Probability of getting doublet, who is going to tell me? If I throw a pair of dice only once, probability of getting doublet. So it is obviously 6, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 6 upon 36, because we are throwing pair of dice. Total outcomes is what? 36. So 1 by 6 is probability of success, and obviously 5 by 6 is probability of failure. Right? Now what you want is 5 times your dice is thrown. So 5C. Now twice you want twice. You want 2 success. What is success? Getting a doublet. 5C2, 1 by 6 raised to power 2, and rest 3 will not be not getting a doublet. So this is your final answer. Okay? Clear? So doublet is this 1, 1, 2, 2, 3, 3, 4, 4,4, 5,5. Probability of getting a doublet is 1/6. Not getting a doublet will be 5/6. Very easy. Right? And now probability will be what? NCR P raised to power R n minus R. So 5C2, 1/6 ka square, 5/6 ka cube. Right? Getting it? Yes? Okay. Now one question. Proper question is this. For an initial screening of an admission test, a candidate is giving 50 problems to solve. Okay. If the probability that the candidate solve any problem is 4/5, okay, then the probability that he is unable to solve less than 2 problems. Okay. Now please understand. This is with a little bit twist. Okay. So straightforward question will be probability of getting exactly R success. But there are questions wherein they ask you probability of getting at least R success. What do you mean by at least 2 success? Probability of getting at least 3 success. Probability of getting at most 2 success. Are you getting the point? Right? So probability of, let's fix it. Probability of getting, okay, maybe, for example, let us go previous. Isme. Probability of getting a doublet at least twice. Doublet, if I just write at least twice, at least. That means what they are saying is probability of getting success. That means probability of getting doublet 2 times plus probability of getting doublet 3 times plus probability of getting doublet 4 times plus probability of getting doublet 5 times plus probability of getting doublet 6 times, right? Maximum 6 times I can get the doublet, right? Because doublet 5 times, that's it, 5 times, yes. Because 5 we are throwing 5 times now. So all 5 times I am getting doublet, right? So sometimes they ask sum of all the probabilities, right? This is what they are asking. So you can just go ahead and calculate this, or what you can do is 1 minus probability of 1 success and 0 success. That means 1 minus probability of getting 1 doublet and 0 doublet. They both are same. So how do you solve it? So 1 minus 1 doublet. If you want to get 1 doublet, so this is 5C1, 1 doublet, and 5/6 raised to power 4. Then 5C0, 0 doublet. That means all failure. So 5/6 raised to power 5C0 and 5/6 raised to power 5. All 5 places we are getting no doublet. So this is what your answer will be, or directly you can do it from here as well. Chiranjeevi, incorrect you did, na? You are missing one more case. Doublet once. No. Probability of getting doublet once and probability of getting not a doublet. Okay. So either this or this will be your answer. So sometimes what they do is they just ask you getting exactly twice, doublet exactly twice. They can give you, and sometimes they can give you at least once, at most once, like that. Okay, that's what I want to tell you. Now let us come back to this question. For an initial screening of an admission test, a candidate is given us 50 problems to solve. If the probability that candidate solve any problem is 4/5, probability that is unable to solve less than 2 problems. So over here, n is equals to 50, right? Probability of that he is unable to solve less than 2 problems. Okay, let us solve this. So now, probability of success. Can you see? He is able to solve something is 4/5. But what they are asking, they are giving probability that he is able to solve is 4/5. But what they are asking is unable to solve. The probability that he is unable to solve is 1/5. And probability that he is able to solve will be 4/5. Clear? समझ में आ रहा? Are you getting it? This time success is what? Unable to solve is success. And able to solve is failure. Because they are asking like that. Okay. And now, how many times they are asking that he is unable to solve less than 2 problems? Okay. So what does that mean? Less than 2 solve problems. What does that mean? That he is not able to solve any problem. Not able to solve any problem. And not able to solve any problem. And not able to solve one problem. Less than 2 means what? Less than 2 means what? 0 or 1. So not able to solve any problem, that means 0 problem. Not able to solve one problem. Right? So 1 problem. So now this time 50. So 50 C1, 1 by 5 is probability of success and 4 by 5 is failure, plus 50 C0 and 4 by 5 raised to power 50. This is your final answer. If you solve it, you will get your correct answer, which is matching with which option? Option D, I guess. Yeah. Have a look. Okay. Now random variable. What is random variable? Random variable, okay. But you know what? Random variable is extremely easy. Extremely easy. But there are very large group of students basically which are not able to understand random variable. Who all does not understand what random variable is, or who all understand what random variable is? I just want to know. Let's take a poll. Do you understand random variable? Because if you don't understand random variable, na, right now is the time that you should understand it, because it is very easy. Random variable is nothing but the counter function, you can say. Okay, so you are doing something, you are doing an experiment. Okay, an experiment can be anything. Tossing a coin, throwing a dice, right? And in that, you must be getting even number, you must be getting odd number, you must be getting 1, you must be getting 2, 3, 4, 5, you must be getting head, you must be getting tail. Okay, so what you do is, random variable is actually, yeah, so tossing 2 coins, basically tossing a coin 2 times in success, or you can say that you take two coins and you are tossing them. 2 coins together, tossing 2 coins together, right? If you toss 2 coins together, what happens? Both will be head. First head, second tail, first head, or both tail. These are the outcomes, right? Now, random variable is nothing but a counter. He just count randomly. For example, you are sitting with your friend, okay? And people are coming and going. And you're just counting that how many people are wearing a black dress. This is also a random variable. So random variable will be what? Counter. And now random variable X, capital X, it is denoted by capital X. So black dress. Suppose I am wearing black dress. If one person is wearing black dress, the random variable will be 1. If 0 person is wearing black dress, the random variable will be 0. If 2 person, 3 person, right? Okay. Are you getting my point? So this is the random thing by which you can also do randomly sitting right in front of the mall. People are coming from the mall and you're just counting that, okay, how many people are wearing black dress? Okay, like that. Okay, all right. Now X. So you can just make it up. Maybe not black, then you can just think about red dress as well. Maybe not red, or you can just think about that how many people are actually, how many girls are wearing lipstick. You can just sit outside the mall and judge that, okay, this girl is wearing lipstick, X equals to 1, like that. Okay. Now, X denotes the number of heads obtained, then X is a random variable. Now, this time, capital X random variable will denote what? Number of heads. So, in first time, number of heads are 2, X equals to 2. Can you see X is taking value 2? Here X is 1, here also X is 1. and here x, because there is no head, 0. So random variable can only take these 3 values. Except these 3, random variable cannot take any value, any other value. So random variable can be 2, random variable can be 1, random variable can be 0. This is your random variable. Okay, this is your random variable. So whenever something is happening, some experiment is going on, some tossing of a coin, throwing of a dice, or 2 dice or 5 dice or whatever. So you just want to count something that depends on the question, the examiner or you, right? Suppose if I am the examiner, I will think about, okay, so random variable, if you throw a dice, random variable can count the even number. How many times you are getting an even number, right? Okay. Yeah. Now probability distribution. Now I guess random variable concept is clear. We will do problems, but the term is clear. The term should be clear. Now probability distribution. Right? What is probability distribution? So probability distribution is depending upon random variable. Right? So let me just show you. Again, same example we'll be taking. Right? When 2 coins we are tossing, 2 coins agar if we are tossing, so what will happen? Okay. So probability, now random variable. So random variable was what? Counting the number of heads. Probability of getting 2 heads. That is probability of x equal to 2. Random variable equal to 2. So that would be what? So total out, so 1 by 4, right? Probability of getting 2 heads is what? 1 upon 4. Probability of getting 1 head. So 1 head will be what? 2 upon 4, that is 0.5. Probability of getting 0 head will be 0.25. So what we do is in probability distribution is, first of all, we just think about random variable and we think that what values random variable can take. So depending upon those random variable, right, 0, 1, 2, so this is x equals to 2, x equals to 1, x equals to 0, we calculate the probabilities and then we make a table out of it. Yes, we make a table out of it. Can you see? This is your x, this is your p. Now, random variable will take this value x1, corresponding to that probability will be p1. This is x2, probability will be p2. This is x3, right, and so on. Depends that how many values random variable can take, and depending upon that variable, what are the probabilities, right? So yes, x1 are the possible values of random variable x, and pi are the probability of the random variable, right? Now this is pi, p1, p2, p3. Sum of all probabilities is always 0. Please remember, sum of all probabilities is always 0. For a probability distribution, p1 plus p2 and all the way up to pn is always 0. Right? Yes, very important. All the probabilities should be positive. Obviously, all the probabilities should be positive. Okay. Now, let us do it with the help of one example so that you get actual picture of what is a random variable, what is a probability distribution table is. Okay. A pair of dice is thrown 3 times. 3 times we are throwing pair of dice. If getting a sum of 9 on them is considered success. Okay. So, basically, getting a sum of 9 is nothing but getting a sum of 9 is your random variable, right? So let the number of successes random variable. Getting a sum of 9 is success, which is a random variable. How many success we can get? So getting a sum of 9. So pair of dice thrown, right? So how to get a 9 for a single throw? So 6, 3 and 3, 6. 5, 4 and 4, 5. Then we have, that's it. Is that it? 2, 7, no. Yes, so 4. So basically 4 upon 36, 1 upon 9 is something which is probability of success. Okay. Probability of success is 1 upon 9. How many times I can get the success? So I can actually get basically if I throw a pair of dice, so what is the possibility? So I cannot, there is a possibility that I am not getting 9. I am getting something else. So that is x equals to 0 means probability of getting probability of not getting any 9, some 9, okay, right? Probability of not getting some 9. Now x equals to 1 means what? That I am getting, so how many times I am throwing? 3 times I am throwing, right? So out of 3 times, there is a possibility that I am getting a 9 none of the times. So x equals to 0. There is a possibility that out of 3 times, only 1 time I am getting 9. Rest 2 times I am not getting 9. So x can be equals to 1. And same thing. Out of 3 times, 2 is getting 2. The first 2 times I am getting sum is equals to 9. And third time I am not getting it. And all 3 times, if I can get lucky, all 3 times I can get 9. Okay. So now probability of success clearly is 1 by 9. Probability of failure will be what? 8 by 9, right? Now probability x is equals to 0, that means not at all getting out of 3 times, not at all getting what 9. So that means 3C0, 1 by 9 I am not getting. This is probability of success, and all the time I am getting failure. Probability x equals to 1. So 3C1, 1 by 9 raised to power 1, 8 by 9 raised to power. Probability x equals to 3C2. 1 by 9 square, 8 by 9 raised to power 1, probability x equals to 3, 3C3, 1 by 9 cube, 8 by 9 raised to power 0. Now what we need to do is, we need to write the probability distributions, distribution. Okay, so for that I need to make a table, random variable x and probability. When x is 0, my probability is what? Tell me. So 8 cube by 9 cube. 8 cube by 9 cube. When my random variable is 1, my probability is what? 3C1, 1 by 9, 8 by 9 square. When my random variable is 2, this is my probability. When my random variable is 3, this is my probability. Clear? 3C3, 1 by 9 cube, 8 by 9 raised to power 0. Alright? Yes. So this is the probability distribution. That's it. That's it. That's it, guys. Only they have only told us to write the table. We have to learn how to make a table. Now we will solve that probability of this. Now we will solve it. Okay. All right. 2 cards are drawn. Please read the question carefully. 2 cards are drawn successively with replacement from a well shuffled deck of 52 cards. Find the probability distribution of number of aces. Please understand, this is not that the n times number of tiles. This is not that topic. NCR wala topic is gone now, right? But random variables will still be there. Okay. All right. 2 cards are drawn successively with replacement from a well shuffled deck of cards. Find the probability distribution of number of aces. Number of aces. Okay. So minimum, if I am having 52 cards and if I have to pick 2 cards, this is number of aces. This is my random variable. So it might be possible that I am getting 0 aces. You know what is aces? Ikka, capital letter A. So we basically have 4 A's in our deck of 52 cards. Okay, total 4 we have. 2 are black, 2 are red. Okay, so x can be 0, x can be 1. So if I just pluck 2 cards, if I pick 2 cards out of 52, it may be possible that I am getting one A and another is different card. And it may be possible both of them are aces, right? So over here, if I talk about that random variable x, which is counting what? Number of aces, it can be 0 or 1 or 2, right? Now probability of getting 0 ace is what? Probability of getting 0 ace. So 0 ace. So ma'am, out of 52, 4 are ace and 48 are basically non-ace. So 0 ace means 48 by 52 is the final probability. So 48 by 52, right, is the final probability, and basically we are drawing 2 cards with replacement. So again, getting another non-ace is 48 by 52. So we are going to actually get 1 by 12 by 13, 12 by 13, right? Yes, 12 by 13, 12 by 13, 144 by 169, x equals to 0. Now you're getting it? Yes. Now probability of getting 1 ace. So probability of getting 1 ace will be what? 40. So 4 by 52. 4 by 52, out of 4 I get 1 ace, and next I am not gonna get any ace, right? Okay. And also you have to multiply it with 2. Can you see why? Because, so if you are picking 2 cards, so first you are getting ace, second you are getting non-ace. Another thing could be, first you are getting non-ace, second ace. So that's why this 2, right? So 4 by 52 getting an ace, and this is not getting an ace, not ace. So this is 2 into 1 by 13 into 12 by 13. So this is 24 upon 169. And now probability of getting, probability of actually what? 2 aces, both the aces. So simple. 4 by 52, 4 by 52. So 1 by 169, 1 by 169. So this is 1 by 169. Clear? Now you have to just form a probability distribution table. Random variable x, probability x. So when we have 0 aces, so 144 by 169, 24 by 69 for x equals to 1, 1 by 169 for x equals to 2. The moment you add these 3 quantities, what you get is 1. Always you should get 1. If you're not getting 1, that means something is wrong. Okay. Now let us solve one question for this. Okay. All right. A random variable x has this particular probability distribution. We are looking for probability of x greater than 2. That means we are looking for probability of x equals to 3, 4, 5. So which is going to be k plus 2k plus 5k square. So 5k square plus 3k is what you are looking for. Okay. But you don't know the value of k. You don't know the value of k. Okay. So for that, I already told you sigma px will be equals to 1. That means k square plus 2k plus k plus 2k plus 5k square is equals to 1. 5k square. So 6k square plus 5k is equals to 1. What does that mean? What does that mean? That k, so 6k square plus 5k plus k minus 1 is equals to 0. So 5k है ना, 6k minus 1. Yes. So 6k minus 1. minus 1. Minus k minus 1. Yes. So k is coming out as minus 1 comma 1 by 6. Minus 1 is rejected. Why? Because probability is always positive. I told you. So k is only 1 by 6. So this is 5 upon 36 plus 3 upon 6. So you are going to get 6 3s are 18 plus 5. So 23 by 36, option C. Okay. All right. Yes. Clear? I hope clear. So yes, sum of all the probabilities is equals to 1. This will give you k is equals to 1 by 6 and minus 1. So minus 1 is rejected because if minus 1 is k, that means probability will be negative, which is not possible. So that's why k is equals to 1 by 6. The moment you put 1 by 6, you get which option correct? 23 by 36. Okay. All right. So yes, we have a lot more topics to cover. We have some topics in conic section, some topics in calculus, some topics in vector and 3D as well. And some topics, yeah. So, and some topics in statistics. So many things are still pending, but we'll keep it till here and we'll take another session for that. Okay. Clear? Okay, so we'll take another session for JEE Advanced remaining topics. And yes, so I'll be coming back for JEE Advanced, right? Yes, shall we do it? One more session for JEE Advanced, deleted topics, and then there will be more sessions as well. Once we are done with deleted topics, then we will be doing some more things, okay? All right, yes. So let's keep it till here. And I'll be coming back super soon, okay? All right, yes. So this is me, Namrata. When is continue session? Super soon, I guess. Tomorrow you are having a chemistry session, again additional topics. So I'll be trying to take a session maybe tomorrow, or if not tomorrow, day after tomorrow, okay? Because chemistry is also in line, all right? So this is me, Namrata, signing off. I'll see you all in the next session very soon, okay? Tomorrow or maximum day after tomorrow, okay? All right, chalo, bye bye, see you.